Hi everyone! Work in the field of automated driving and autonomous mobility requires many multifaceted processes incorporating a variety of software tools, introducing a new complexity into the development. This complexity rises with each level of control and autonomy of the automated driving systems. The tool chain for such challenges is also complex, and the integration of all the tools coming from different domains cost a lot of effort without a real competitive advantage towards the automated driving solution. Welcome to my session, Autonomous Driving and Open Source. Is this a good idea? And get some insights into leveraging open collaboration models and open source software in the competitive and demanding automotive industry. Learn about existing and upcoming working groups and software projects in this domain and how to use it. So I'm Andy, working for Bosch as a technical product manager for autonomous driving. I'm with Bosch for 23 years, therefore 15 years as embedded software developer in different product areas. Since end of 2016, I'm working in the area of autonomous driving, bringing open source into automotive. So talking a bit about the challenges and the complexity of autonomous driving. First of all, the car has to know what's going on in its environment. Second, it has to be able to pinpoint its location in order to know exactly where it is. Are we in Stuttgart in Germany or in Stuttgart in the US? Are we on the right driving lane or on the left? So this is a real important information. Third, based on that information, the car must interpret, plan and decide how and where to move. That means it has to process the data received from its sensor and the cloud. Fourth, based on the data, it has to find the best trajectory for the driving task, which will then be executed by its actuators. Automated driving technology is based on artificial intelligence principles. We all have experience which help us make driving safer. Giving experience to the car is the idea behind Bosch's exploration of artificial intelligence principles like machine learning. The AI onboard computer is the brain which can interpret, decide and execute in concert. Looking a bit around what is going on, you maybe noticed that open source arrived in automotive now, and that is really good. Because some years ago, open source and automotive was a real no-go. Here you can see some examples. For example here, Autonomy's future is open source. The Automotive Foundation open sourced interfaces and tools. Uber open sourced ABS, an open source standard for autonomous vehicle visualization. Kala, an open source simulator. Kama from the US Department for Transportation, dealing with vehicle-to-X communication. LG open sourced a simulator for the ROS framework. Tesla published code from their Model X and Model S. GM Cruise and Uber open sources a visualization tool. Continental published eCall, an enhanced communication abstraction layer. Audi published an autonomous driving dataset, libraries for machine learning, and their functional engineering platform for simulation and testing. Why do we talk about open source and what is the motivation for that? While it may seem paradoxical, but we are convinced that open source is actually the best way to reach a wide range of business goals. First, let's look on the left-hand side. How open source software works for companies. BASE is partition software into differentiating and commodity parts. Commodity parts can be open source, differentiating parts should stay proprietary. Question whether a piece of software is commodity or differentiating often depends on time. What is a USP today may be commodity in a couple of years. Shared development means, in general, the partners give and take software based on a common repository. Now the right-hand side. What companies gain from open source. Above all, efficiency in various dimensions. Open source allows agile collaboration with a minimum of formality, as opposed, for example, to consortia. Visibility to many eyes increase quality. Contributions from many partners increase development speed, share risks, and reduce costs. In the software industry, there is tendency to the winner takes it all, but open source helps to minimize dependency on suppliers and break or prevent proprietary monopolies. Experience with other open source projects has shown that openness accelerates market penetration and even create a new market. Most importantly, shared commodity is competitive advantage for various reasons. Companies can focus on the differentiating parts. Shared commodity creates a mainstream which tends to eliminate proprietary alternatives from the market. In total, I am deeply convinced that a toolchain for autonomous driving is an excellent case for collaboration in an open source project. Therefore, we started OpenADX. OpenADX was launched at the Bosch Connected World in February 2018, but we started beginning of 2017 with the first steps, some workshops and partnering activities. During the conference, Dr. Dilko Eisel, Robert Bosch Group Board of Management, outlined the targets and kicked off the initial testbeds which were worked on in a hackathon format during the 3 days of the Bosch Connected World. The BCW, the Bosch Connected World, provided a good forum for the kickoff with approximately 3,000 participants from various industries working in high-tech. OpenADX was brought up in several follow-on presentations by other organizations, identifying it as an important step in the use of open source for attacking complex problems areas in the automotive industry. As mentioned, developing autonomous driving functionalities needs a lot of tools. Often, you choose best-in-class tools, which are not designed to work together with other tools from different tool vendors. To make them work together, you have to build some connectors, and every company is doing that by themselves. This costs a lot of time and money. So therefore, we initiated OpenADX to mitigate these problems and to accelerate time to market, to share costs and risks, and free up resources to focus on the real customer needs. By defining an industry-wide accepted AD toolchain with high interoperability and easy access to establish the base for a reference architecture. We found with the Eclipse Foundation, please do not mix it up with the Eclipse IDE, a host which supports us. The current members are Microsoft, Bosch, Denso, Red Hat, AdLink, AVL, Iteration, Eclipse Source, eThemis, JSIM, Science Plus Computing, Siemens, the University of Applied Sciences in Dortmund, Open Robotics and the Automotive Foundation. Our goal is to integrate a range of existing products into the development suite. You can see here the blueprint. We know it is not 100% complete, but it is a good starting point for discussions and agreed by the current members. The color code shows many specialized tools from different vendors. Horizontally, you can see toolchain examples from different companies. As companies invested in their toolchain with buying licenses or training of the employees, we do not want to define the one and only toolchain. No. We focus on the tool interfaces and the data models to ensure interoperability and exchangeability of the single solutions. We believe an initiative like this should be inclusive, not exclusive. This will ensure transparency and make a complex toolchain more accessible to enterprise users. OEMs and Tier 1s will benefit from the integration with increased efficiency. Being integrated in a standardized toolchain framework makes the tooling providers more attractive to the companies using their products as well. In other words, everyone wins. With OpenADX, you can build your own software development toolchain and start developing cool functions which you can sell at the end. I believe a toolchain must be in the cloud to guarantee easy access and to ensure hardware independency. With a marketplace which contains tools as well as software functions, open source as well as proprietary solutions, you can start building your own environment and products. The marketplace offers you also the possibility to bring in your solutions like tools and pieces of software. The products can consist of available parts which you will find in the marketplace, or you can develop them and can bring them back. From developers' perspective, with over-the-air capabilities, you can shorten the way between development and car because you are able to access the vehicle directly and get data which you can process in the cloud. Together with other open source initiatives, OpenADX lays the foundation for safety and standardization. The Eclipse Foundation hosts automotive working groups who are dealing with measurement data handling, so it's the working group OpenMDA, verifiable and understandable AI, OpenGenesis, urban traffic simulation, SUMO in the Open Mobility Working Group, virtual simulation in the OpenPath Working Group. There are also some public funded projects which we consider for our work because we do not want to reinvent the wheel. We will use existing solutions and we will bring them in. With App4MC, an exchange platform for timing and performance simulation, Eclipse Cuxa, an automotive platform, and Panorama for design efficiency, there are some automotive projects available. Some standardization organizations like ASAM and Modelica are also helpful to bring open solutions forward. With open hardware, so there are also some open hardware projects like RISC-V, you can design a complete software development kit. Here are our current open source projects. Eclipse Chloe, a simulation middleware which connects and controls the real simulation engine with the software under test, providing a user interface to see what happens during simulation and to adjust some parameters. Chloe is a kind of abstraction layer which connects the simulation engine, open source or proprietary, with the software you want to test. In this case, we test the autonomous driving software stack, which is typically proprietary. In our automotive middleware, we have also an open source part in, it's called Eclipse Isorix, which you can use. Eclipse Isorix is a middleware with a zero-copy shared memory approach, which is optimized for the huge data inter-process communication. Zero copy means we do not copy messages data at the beginning of the execution of functions, we handle references. For more information, please have a look into the project descriptions. Here you can find more details about Eclipse Chloe or our simulation middleware. So currently we are in the process of the initial contribution, so stay tuned that you can find here some available sources. Here you can find more about Eclipse Isorix, the middleware with zero-copy shared memory approach for the huge data amount for interprocess communication. Eclipse Cyclone DDS, an implementation of the OMG DDS specification, finds its place also in the OpenADX working group. Originally designed for IoT, Cyclone DDS is going automotive and Isorix will be integrated. So then we have a real powerful implementation for middleware, which you can use at the end. So here you can find more information about Cyclone DDS. To sum up, open source software is gaining traction in the automotive industry. It minimizes dependency on suppliers, increases quality through broad testing reviews, skilled attention, broad expertise, enables risk sharing and cost reduction, will be essential to the success of partnerships and consortia. Our open source based software toolchain for autonomous driving will support the integration of tools along defined development workflows, fill identified gaps along those development workflows. So open source and open technologies helps to collaborate in a changing automotive market. So this is a real good idea to combine autonomous driving with open source. And I invite you to be part of this great initiative. So find here most of the links from my presentation. So for example, our website, the wiki page, some blog posts, our projects Isorix, Chloe, App4MC, Cuxa, and so on. So thank you for participation in this talk, and now I'm open for questions. Thank you.
So I saw a question, how do you manage the development across all these different players and projects? For example, which features, tools get priority, etc. So currently we are in the steering committee of the OpenADX working group dealing with exactly this one. Means we are currently preparing a program plan to define exactly this, what should be next, what could be our next work package, what do we need for that, and so on. And of course also the priority on that. So from a technical perspective, what are the major challenges in all these integration efforts between the different tools? So to be honest, we are still at the beginning, and we started also to build up a co-simulation demonstrator in the area of simulation, and therefore we will get the first experience, what will be here the difficulties, the differences, the stuff and so on, what we need for that. So we are also looking for some used standards, for example, the OC interface. Then there are also some further standardization stuff for that, like Open Scenario, Open Drive, where you can, which is often used in the area of simulation. And maybe with this stuff, we can start here building the standardized tool interfaces, going then also to the tool vendors so that we can get them in there to build together with us here the tool chain. Because if they can serve a lot of people, a lot of customers with a out-of-the-box solution, then they also win, and this is also a big benefit for them. So can we have access to the slides? Of course. We are an open community. So for example, if you use Google, you can Google for OpenADX, then you will find our website. It's openadx.eclipse.org, and there you will find the white paper. So it was just released in July. You can have a look who is also the member or the current memberships in our working group. You can have the links to the current projects we have. Then there's the link to the wiki, the OpenADX wiki. So there you can find the presentation, but it's not really hidden, but you have to know that you have to jump to the end of the site. So really on the bottom, and there you find the link. It's under the asset area. And yeah, feel free to download it. You can also contact directly me. You will find me via LinkedIn, Andreas Rixinger. So yeah, you can find me, of course. And yeah, so we have access to that. So I'm just looking for further question. Could we use Cuxa for remote management of industrial robot and sensors? Do you think it would be feasible idea, and its software stack could help us? I guess yes, but surely we have to have a deeper look on that. So what we are currently doing is, together with the Cuxa guys, is trying to make the tool chain they have available in the cloud. I guess there is currently a link available, but I have it not with me. Sorry for that. So yes, we can talk also later on that. Yeah, please contact me, and let's see what we can bring out of that. So the next questions I got, do you think you can really convince all the existing rather traditional management department and etc. at Bosch and others to switch to your open source approach to agile development, or do you imagine this to become a parallel kind of organizational setup? So yes, for traditional companies, especially in the automotive industry, it's a bit tricky. But as you see, we have currently two open source projects out there. One is not in the tool area. One is in in the area of the ECU. It's Eclipse Isorix. So you have here the true zero copy shared memory approach, and therefore, yes, we can convince the management. But yeah, and I'm lucky to have here a supporting management to do that. But it's in general still a way to go in this way. I hope this answers your question. So For the system architecture and functional analysis steps, it is possible to use Eclipse Capella. It would be helpful for the top left side of OpenADX process. Yes, of course. So what I currently started is based on the Eclipse THEA mechanism to write the first extension. But it's, yeah, do not expect too much out of that because I'm some years out of software development. So I try to come back into that. And currently it's more menu entries you have, but we can fulfill that. So yes, of course, Capella can be used within them because for model-based software engineering, we need a solution, and we will also look to other solutions, of course, because our approach is to have the exchangeability of tools. But for first step, of course, we can use Capella therefore. Cuxa uses a lot of the normal Eclipse IoT. Oh no, those definitely can be used. Yeah. Further questions? Did I get all the questions in the chat? I'm not sure. Okay. So yeah, I guess we have still some seconds left. Yeah, of course, you can contact me. I can write my email address in the chat after that. And yeah, let's connect, stay in contact, and help us to form here the autonomous driving toolchain or the automotive toolchain, or better, the toolchain for mobility solutions. So thanks you. It was a pleasure to have the opportunity to talk to you. And yeah, have a good EclipseCon. Thank you.